Today we are going to work on cube root functions. This will be a guided practice, which means I'll do one and I'll give you a chance to do one on your own. We're going to be working on TEKS 2A, which is the parent function attributes, transformations of the parent function, and domain and range. So this is a cube root parent function. Some of the key attributes is that it crosses through the origin at 0, 0, and this graph has rotational symmetry. But to discuss domain and range, my domain and my range are going to be identical. So domain is going to be my possible x values, how far to the left, how far to the right. Well, this graph is going from negative infinity because it's going forever to the left and forever to the right. And since it's never going to actually touch it, we use parentheses. As inequality, we say that negative infinity is less than x is less than infinity. And in set builder notation, this reads x such that x is equal to all real numbers. And yes, I've seen set builder written in a couple different ways. Sometimes you have the inequalities written in here, but all real numbers. So the domain can be any number. So our range value is going to be the possible y value. How low is this graph going to how high is it going? Well, just like the domain, the range is going to go down forever and it's going to go up forever. And we use parentheses since we will never touch infinity. Less than y less than infinity. And set builder would read y such that y is equal to all real numbers. So now we get into the transformations. So to discuss the transformations, a will always be in front of the radical. A is going to be a vertical stretch if the absolute value is greater than 1. A will be a vertical compression if the absolute value is between 0 and 1. And if it's a negative, this causes it to reflect over the x-axis. The b value is inside the radical. It is either in front of the parentheses or it's attached to the x value. B is a horizontal stretch or compression, and if B is negative, it causes it to reflect over the y-axis. H will shift the graph left and right, but it's always going to be the opposite sign of what you see since it has a negative in the equation. So whatever you see here, you have to change the sign. And K is going to make your graph go up or down, so it's a vertical translation up or vertical translation down, or we can also say the word shifted up and down. So I'm going to do example 1, and then you'll try practice 1 on your own. So for example 1, I don't see an a value here because there is no number in front of the radical. There is no number in front of x, therefore the b value is a 1, which doesn't cause any kind of translation. So then we have these two numbers. H is the number that's underneath the radical, but H is always going to change signs. So in this case, H is a negative 3. So this graph is actually going to the left 3 units, shifted left 3 units. My K is this number on the outside. It's a negative 2. So this graph is going down 2. And since there's no asymptotes here, my domain and range are never going to change. My domain and range are always going to be negative infinity to infinity for a cube root function. Okay? So go ahead and pause this video here and try the second one on your own and look at these 3 numbers and what they're doing to the graph. Okay, go ahead and check your work. Something here, the 2 is a vertical stretch because remember we're talking about the absolute value. So this is a vertical stretch of 2, but since it's negative, the negative caused it to reflect over the x-axis. The h value, we always change the sign, so the h is a positive 2, the graph went right 2. The k value at the end is a positive 6, so the graph went up 6 units. Remember that the domain and the range do not change for cube root functions. So we're going to do exactly the same thing again. This has an a value of 1/2, and so the 1/2 causes a vertical compression. I do not have a b value here. A b value would be the number in front of this. And don't forget that when we're discussing the b value, when we say the amount of it, we always take the reciprocal. I want you to listen to that carefully for your next question. but for mine, we don't have a b value. The h value, we always change the sign, so it's a positive 2. This graph is being shifted to the right 2 units. And the negative 5 at the end tells me this graph is actually shifting down 5 units. So you can say this graph translates down 5 units. My domain has not changed. I'll write this one in inequality form. Negative infinity is less than x is less than infinity. And for the range, it's a y instead of an x. So go ahead and try the second one. I want you to pay very, very, very close attention to this negative 2 here and use the sheet that tells you what this value does. Go ahead and pause this video here. Okay, I know that this b value usually messes up a lot of students, so let's talk about that b value here. It's a negative 2. So we don't look at the negative, we look at the 2. If b value is a 2, that's a horizontal compression by the reciprocal, so by 1/2. The negative caused it to reflect over the y-axis. And the 6 on the outside is a k value, and this graph went up 6. Now notice the domain and range, they did not change. Okay, so example number 3, we're going to talk about transforming the graph, how to translate it. So in this case, I have a b value of 3. Remember, a b value of 3 is a horizontal compression of 1/3. And my k value of negative 1 means this graph shifted down 1. And my domain for all of these is going to be all real numbers, or negative infinity to infinity. Now graphing this one's a little bit trickier. We're going to look at this right here, the origin. We know that the graph shifted down 1, so that's going to be the first point I plot. Now I look at when I'm cube rooting something, I want this to be something I can take the cube root of. So I said the first number is 8, but I can't. 3 times what gives me 8? I don't want a decimal. So I'm going to make this a 27. I know this is a little bit technical. So I'm going to choose when x is 9. So when x is 9, I get a value of 2. When x is negative 9, so if I plug a negative 9 in there, I get negative 3 right here. Negative 3 minus 1 is a negative 4. So this graph is going through this point, up through this point, and turning. So this is a horizontal compression, which also looks like a vertical stretch. So go ahead and pause this video and try the second one on your own. Okay, go ahead and check your work there. We had A was 2. This caused a vertical stretch of 2. And H was a positive 4, so the graph shifted right 4. So I always start with my origin, and my origin, that point shifted right 4. And I used my A value to graph the next 2 points, and it's a vertical stretch of 2, so up 2 over 1, and also down 2 over 1. Okay. So this again, now we're going to look at these graphs. This one's a little bit different here. Here's the parent function and what happened to it. So let's look at where this graph translated to. So my origin, I'm looking at this graph, and where's the center of this line? Center of that line is right here at negative 2, 0. And I look at other points that I have, and I look at another point that I have. So I'm going to use these points to help me with this graph. So I start here at the origin, and I see that the graph shifted right 2. So I know that my h value is, left 2. So my h is a negative 2. The graph went left 2. Now I can tell that this graph has a vertical stretch. How much is that vertical stretch? Well, I look here from this point, and this graph went up 3 over 1, and the graph went down 3 over 1. So I'm confident that my vertical stretch is a 3 because it had a vertical stretch of 3. Okay. So those are all the values that I have here. And so for my equation, this is going to be f of x equals my a value. Now this is a cube root graph, so the cube root of x plus 2, because I always change my h value. And my domain and range are never changing. My domain and range are negative infinity to infinity for both of them. Okay, so go ahead and pause this video here and see if you can find the translations, equations, domain, and range of practice number 4. Okay, now check how you did here. I saw that this graph shifted to the right one because I kind of look at this straight area and this was the middle. So that means that my h value was a positive 1. And I found my next point that went through a corner, and this went up 2 over 1, and I checked the other way, down 2 over 1. That tells me that my a value had a vertical stretch of 2. When I wrote this equation, the negative 1 is underneath the radical, and domain and range are negative infinity to infinity. Okay, so just a couple more. Go ahead and pause this video. We have 2 more practice ones for you to do on your own, doing what are the transformations and how would the graph look like. So pause this video here. Okay, so go ahead and check your work. We had the a value of 1/4, which means I had a vertical compression of 1/4. There was no, b value was 1, no horizontals. Right 1, up 2. So the first point I moved was the origin. I went to the right 1 and up 2, and this was the first point. And since the a value was 1 over 4, I was able to use the a value 1 time to go up 1 over 4 and down 1 over 4. And this is an example of a vertical compression. Now our last problem of the day, I want you to go ahead and try the same thing. Go ahead and pause this video here and try this problem on your own. Okay, so this was our last one that we're doing today. A was 4, caused a vertical stretch of 4. This caused the graph to go left 2 and down 1. Again, the first point I moved was the origin, left 2, down 1. And because A was a vertical stretch of 4, I went up 4, 1, 2, 3, 4, over 1. And I went down 4 and over 1. And this is an example of a vertical stretch. Hopefully this video helped you practice transformations of the cube root parent function.